answer?
So yesterday we went over numbers 2, 4, 6, 8, 10, 12. And what is this called? A sequence. That's correct. So, as it is a sequence, it's a little slow.
Try. Like hitting a reader with programs on there.
Now, today we're going to cover something that has something different. Now, it's going to be 2 plus 4 plus 6 plus 8 plus 10 and plus 12. Because now it is an addition. It's a summation, very good. But the proper name for it is a series. Now, that symbol right there is known as your summation symbol. Okay? So when you see that, it means there has to be some type of adding. You're not just going to be listing. So it is a summation symbol, notation. That's basically what they call it. Now, have you seen it before?
Yeah.
Hopefully you guys don't have a hard time writing it and make a big deal out of it, but there it is.
Isn't it just like an M, like the two things?
Like an M or like an E, but yes, sideways, something like that.
No.
Now, here goes your first example. Let's say you are given 3 plus 6 plus 9 plus 12 and plus 15. First thing we need to do is label our terms. We're starting off with what term number? 1, 2, 3, 4, and 5. Now, what is the pattern here? How am I getting a 3, a 6, a 9, a 2?
Multiplying by 3.
N times 3. 3n multiplying times 3. Your 3 are right. So this is really a, and I forgot. There goes the 3. It is a 3n. Are we good? Now, we could check it by doing that right there. Is 3 times 2, 6. Is 3 times 3, 9. Is 3 times 4, 12. And then you could try the 15 if you want to. Now, the point here is, how do I write this as a summation problem? Well, first, let's put our little summation after we do that. Now, your summation has two numbers when you have the actual problem. It's going to have a number up in the top and up in the number on the bottom. The number in the bottom is called your index, which I like to go back and recall it the initial start point. So what was my first term number?
3.
My term number, not my actual sequence. It was a 1. So this is where you put n is equal to 1. Are we good? But I stopped where? But what term number was it? At 5. So you go from 1 to 5, you're only looking for the first 5 numbers. That right there is called your upper limit, or I like to call it the, I don't even know, the stop point, where it stops. Now, because you guys knew that the formula was 3n, I put it afterwards, and that's my answer. So you're given points, and those points, you have to find the formula. You need to find your initial point and your upper limit. That's it. It's not that bad, right? Okay, well, let's find out. Now, let's look at the next problem. Let's say this is the example they give you. Now, if you had this problem, so it's a summation from 4 to 8, and the formula they give you is 3 plus k squared. Now, what do you think you have to do here? Who am I going to change to 4, 5, 6, 7, and 8? The k. So the first thing is doing the k. So we do 3 plus, oh my gosh. Alrighty. So it is 3 plus 4 squared, and then 3 plus 5 squared, and then plus 3 plus 6 squared, and 3 plus 7 squared, and 3 plus 8 squared. So you have to do it every single time. Now, if it went from 4 to 100, you would have to do it. Crazy, right? Now, the ones on your assignment, there's only about 2 or 4 terms that you have to add. That's the most. So when I do this, what is 4 squared? Plus 3?
19.
Okay, so we have 19 plus, what's 5 squared?
25,
plus 3,
28,
28, 6 squared,
36,
plus 3,
39,
39 is correct, and then 7 squared,
29,
plus 3,
52,
52, and then the last one, 8 squared is
64,
plus.
67.
Now, when you add all those up, what does that give you? Use the calculator, I hope.
I do this in my head.
What is it?
It's for 200, 202. I got 202.
Somebody add it, please.
202.
It's a 205. 205. Maybe you mistyped something. I don't know. Okay, for the next part, you are given a specific formula. Now, this formula looks like this, and it looks weird. But basically what they're saying is, once you figure out the pattern, and the pattern is just I or just N or K, depending on what variable you're using, there's this formula that you could use that will help you solve that problem. Very easy. And it's N, parentheses, N plus 1, divided by 2. So what would be an example of this if you had a problem like this? 1 plus 2 plus 3 plus 4. And it would keep going until you add 530. Now, can you imagine going on your calculator? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, all the way until you get to 530? Wouldn't that be kind of crazy?
I'll get a head start.
You'll get a head start. Then go for it. Let's see who finishes faster, you or me, once I use this formula. First thing is identifying your terms. So first I know that I start off with what term? First, second, third, fourth. Do I know what term that 530 is?
530.
Why? How do you know it's 530?
Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So what do you think your rule, your formula is? So it's just N. N1,
Done.
it's just N. So this guy is going to be 530. The formula is going to be N. That's what it is. That's what it's going to be because the number repeats. So the thing here is I am doing a summation. And I started off with what? N being who? My term number, what's the first one? 1. And I'm stopping where at? 530. That's my upper limit. And we said the formula was N. So this looks just like that top formula, except they use I's up there instead of the N that we're using. So it's just a different variable. But it says the formula I should be able to use is N, but N is usually what number? The number where? On the top. So who is my N for this problem? 530 times 530 plus 1, and then you divide all that by 2. So this really is 530 times 531 divided by 2. Can somebody tell me what that right there is? 1,140,700 and what? 15. Now that right there would be your answer. Now, if you would have kept going 1 plus 2 plus 3, eventually you would have gotten that. You would have gotten that answer, 140,715. So, is it a lot easier to use the formula? Yes. Now, you are going to have a problem on your assignment where you're going to have to do this. So, make sure you know, okay, it's just a variable. They may use N, they may use an I, they can use Q, R, S, T, U, V, as long as it's just a variable by itself. Now, the next thing here is a new formula.
So that's the one.
This is the last formula you're going to learn, the last thing before you actually have to start. Now, this formula, you're going to use it when it's the same thing. It starts with your I being 1. My N is on top. But you're going to use it when you get an I squared, or an X squared, or a V squared, or R squared, something squared. Now, the formula looks a little like, are you sure, Miss Peña, this is a lot easier? Yeah. Excuse that. This thing's driving me. N plus 1, and then 2n plus 1, all of it over 6. So this is just a 1 right there. N plus 1, 2n plus 1 divided by 6. So let's say you got an example. And the example that they give you, and this is going to be example 4 in the last one, it's 1 plus 4 plus 9 plus dot 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 plus 144. So let's say that's what you got. Oh, sorry. Now, how many numbers? I start off with what term?
1.
1. So this is 1, 2, 3. What am I doing? How am I getting the squaring it, right? So the formula seems to be n squared. So this is going to be my 12th term. Very good. So when I do my summation thing, I start off with n or I, whatever you want it to be. N is equal to 1, and it stops where? On 12. And the formula is n squared. So because it's an n squared, on top we have an I squared, but it's the same kind of problem. My n for this problem is going to be who? 12. So this is going to be 12. 12 plus 1. 2 times 12 plus 1. All of this divided by 6. And it looks like Miss Peña. Did she even put a 12 there? I don't know. But it is supposed to be a 12, sorry. 12 plus 1, 2 times 12 plus 1. Oh my gosh, I don't know. But let me just finish it off, but I think you're right. So this is just really 12 times 13. And then what's 2 times 12 plus 1?
26. 25.
25. And all this divided by 6. So when you put into the calculator 12 times 13 times 25 divided by 6, the answer is 650. Now, if you look at your worksheet from yesterday, sure that we know which terms they are. This is my first, second, the third, the fourth, and the fifth, and it keeps going. Now, how or what would you think the formula to get these numbers is? What am I doing to that? So if we look at it, it is supposed to be n squared minus 1. So if we try 1 squared minus 1, that's...
He said 3.
Sorry, you see? Chihuahuas. So when we do this, it is going to be 1 minus 1. That gives me 0, so that doesn't work. But Mr. Navor, you said it would be a minus 3. So 1 squared minus 3, is that a negative 2? Yep. 2 squared minus 3, that's 4. Minus 3, that's a 1. And then 3 squared minus 3, that's a 9. Minus 3, is that 6? Yes. And if you keep trying it, yes, this is the formula. But they're asking you, can you please write it with a summation? So the summation would be like this. And it would start off with the first term, correct? But does it stop? What do those little dots mean?
Infinity.
Infinity. So we need to put an infinity on top and just put the formula here. And that's it. That's all you do there. Thing is, number 19 has a typo that 3 in the bottom should actually be a 4. Now, that should hopefully help you. But remember, this is the first, second, third, and fourth. So this one does stop. When you guys put your little final answer, make sure that you put your initial and your stop on the top. But what looks like the formula for the top? N times 2, and that's correct. Because if you do 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and so on. And what's going on in the bottom? N plus 3. Very good. So we have 1 plus 3 is 4. 2 times 3 is 5. 3 plus 3, and so on. So this here is your formula. Your job is to finish up the summation, putting the numbers in the right spot, and putting the answer, like the equation afterwards. So basically done with you. You just need to know how to stop it. Make sure you do 20, 21, 22, and 23, so you only have 4 more problems to do from that worksheet.